Pairwise comparisons, correlated observations. When doing all pairwise comparisons among independent groups, the Turkey test is the recommended procedure. However, when each subject is tested in each condition, the Turkey test makes an assumption that is unlikely to hold, that the variance of the different scores is the same for all pairwise differences among conditions. Thus, another procedure is often used when doing pairwise comparisons with correlated observations. The standard practice for pairwise comparisons with correlated observations is to compare each pair of means using the method outlined in the section The Difference Between Two Means Correlated Pairs, with the addition of the Bonferroni correction described in the section Specific Comparisons. For example, suppose you are going to do all pairwise comparisons among the means of 4 conditions A, B, C, and D, and you want to hold the family-wise error rate at 0.05. First, you would perform a significance test on the difference between two pairs of means. Then you determine if the p-values you computed are statistically significant given the per-comparison error rate determined by Bonferroni correction. Because there are 6 possible pairwise comparisons among 4 means, you would use 0.05 divided by 6, which equals 0.0083 for the per-comparison error rate. Thus, there would be a significant pairwise difference if a p-value were below 0.0083. To recap, while it is recommended that you use the Tukey test when you have independent observations, it is recommended that you compare each pair of means with a t-test and then use the Bonferroni correction when you have correlated observations. To see how pairwise comparisons with correlated observations are done, let's consider the Stroop case study. In this experiment, each subject performed 3 tasks. In the words task, subjects read the names of 60 color words written in black ink. In the colors task, subjects named the colors of 60 rectangles. In the interference task, subjects named the ink color of 60 conflicting color words. The response times were recorded. In order to compute all pairwise comparisons, first, the difference in response time for each pair of conditions for each subject is calculated. The table shows these scores for 5 of the 47 subjects. The mean, standard deviation, standard error of the mean, SEM, T and P based on all 47 subjects are shown in this table for the 3 different scores. The T for each different scores was computed by dividing the mean by the standard error of the mean. Because there are 47 subjects, there are 46 degrees of freedom. Notice how different the standard deviations are. For the Tukey test to be valid, all population values of the standard deviations would have to be the same. Using the Bonferroni correction for 3 comparisons, each p-value has to be below 0.05 divided by 3, which equals to be 0.0167, for an effect to be significant at the 0.05 level. For these data, all p-values are far below that, and therefore all pairwise differences are significant.